Good. So the first rule of said, use of said. So I have a variable a multiplying that said a multiplying a different said, the same said b. Now these are two sets that are multiplying each other. Just like you have a times a being equal to a squared. Right? Good. So now that is said a all squared. Now every square cancels a square root. So you have only example said 2 times said 2 cancels out. And just said 2. Probably you have said 3 times said 3. This is said 3 squared. A square cancels a square root, and a cube cancels off a cube root. We have this is cube root 27 cube. This cube can cancel the cube root. Right? Good. Good. Now the second one is you have a different variable, whole number standing alone, multiplying a set. They just combine. Very, very simple. 3 times set 2 is equal to 3 set 2. Right? Good. Now, if you have the third rule, if you have a variable a, as a separate or a different set, and you have variable b as a different set, and they are multiplying, you just pick one set and they combine. And multiplication is very important in sets. But when you get to addition and subtraction, that is where the difference comes in. Good. So now the fourth rule, we have separate number and set. Now this one actually came from a times set. This one came from a times set. Good. So that is a set from the previous rule. Right? Good. Now rule 5. Rule 5. Rule 5. Now, if you have fraction of sets, if you have fraction of sets, this is what helps us get conjugates. But then you will get the fraction of sets. Now you know that these are all sets and they are divided, so you can just pick one set. For example, probably if you have say 15 divided by say 5, say 15 divided by say 5. Right. Now this can be equal to say 15 divided by 5. Say 15 divided by 5. Very, very, very simple rules. Very, very simple rules. Good. Now let's simplify sets. Let's simplify sets a bit from here. Simplification of sets. Simplification. Simplification of sets. Simplification of sets. Now, you see, if the rational number under the square root sign contains a factor of a number such as 4, such as 4, 9, 16, 25, 36, 49, 64, these are all perfect squares. Good. Etc. Then the said can be reduced to a simpler form. This is done by identifying the largest perfect square, which is a factor of the number. Good. You can just simplify it. For example, all the English that's said. For example, let's say I have said 12. I want to simplify this again. Now I know that obviously I can break 12, right? Yeah. To get a perfect square unit. So what would that be?
3 times 4.
3 times 4. So I have said 3 times 4. Now I can separate them. So said 3 times said 4. Now that is a perfect That will give us a perfect square. So set 3 times what? 2, right?
Yeah.
So this is how we write it. 2 set 3. Good. 2 set 3. Another example. Let's say I have said what? Let's say I have said 27, right? I have said 27. Now how do I break 27 to get a perfect square unit? 9 times 3. So I have said 9 times 3. I break them to sets. So I have said 9 times said 3. Right? So what is the square root of 9? So we have 3 said 3. Very easy. Sets are very easy. And always pass sets. Not very difficult. Now addition and subtraction of sets. Addition and subtraction. Or should I give you a more complex simplification? Let's try and see if we can get this. Said additions and subtractions as we go on. The guy came again. Good. Additions and subtractions of sets. Good. Now we can only add or subtract sets that are of the same form or they are alike, right? Sets that are alike. 2 sets are said to be alike if they have the same number under the root sign. So now how do sets or how are sets alike? It's a straight statement. They have the same number under the root sign. We have the same number under the root sign. The same number under the root sign. So for example, you have said 2 said 2, 3 said 2, 0.649 said 2. These sets look alike. These sets look alike. Good. Now, when you have 2 said 3 and 3 said 2, these are unlike sets. Unlike sets. Why are they unlike sets? Because they have different values under the root sign. They are unlike sets. So we are going to look at their additions and subtractions, and then look at possible examples that we can probably solve. Good. Now the first example we are talking about is if you have a said m. You have m said, let's say k, multiplied by n said k. 1. N said k. And these are sets that are alike, right? Because they have the same values. And as I said in the previous lesson, whenever you are doing mathematics and then you represent the same value in an equation, it means that the same variable in an equation, it means that the value of that number you have represented, they are the same across, right? Good. That is how it works. So this guy is going to be m plus n said k. M plus n said k. Example. I have 3 set 2 plus 6 set 2. So this one is going to be 3 plus 6 set 2. So what is 3 plus 6? 9 set 2. Very easy. Very easy. Right? 9 set 2. Set 2. Good. Now I have, try this and let me see. 6 set 2 minus 2 set 2. 6 set 2 minus 2 set 2. Good.
It's equal to 4 set 2.
Okay, 4 set 2. Good. Good. Now one thing you should know that these guys, they're unlike guys. Set 2 minus set, let's say set 5 minus set 2. This guy is not equal to set 3. It can't happen like that. They are always maintained like this. Set 5 minus set 2. It can't happen like that. So what do you think this is going to be? See, what do you think this is going to be? If I have 2 set 6 minus 2 set 6. Okay, let's see. So now the rule is saying that 2 minus 2 set 6. What is 2 minus 2?
0. So we bring the 0.
What is 0 times any number?
0.
That is 0. Good. A very ugly 0. So that's 0. I mean, that is 0, right?
Yeah.
Good. Good. So the rules hold. The rules hold. Now a said A, a said, let's say A said B. You have A said B. Sorry. You have A said B. Good. It's said to be in the basic form or simplified form if B has no perfect square as a factor. For example, if B has no perfect square as a factor, so now see, anytime I get a value under the set, good, and there is no way I can break that value to get a perfect square, right? Good. It means that is the simple form. That is the simple form. Look assumption. Just as we did earlier. If I have say this set 12. Just as we did earlier. Now we can break this to have a perfect square in it, right? Good. Because I know that set 12 is equal to 3 times 4. 12 is equal to 3 times 4. Right? So I split this set 3 and set 4. That is 2.
Yeah.
That is 2. Right? So I have 2 set 3. This is my simple form. That is the basic form. Good. So you always need to look out for these perfect squares, like 2, like 4, right? Good. Like 3, right? You got 9. 9 is a perfect square, right?
Yeah.
Good. Right?
Yeah.
Because 3 times 3 is 9, right? Good. And 9 itself, and because 81 is 9 times 9. Good. Good. 36, right? 7 times 7 is 49. 8 times 8 is 64. 9 and 81. And 10 times 10 is 100. What is 100 times 100?
10,000.
Yeah. Go 100 times 10.
10,000.
Yeah. That's 10,000. What is 100 times 1 billion? We leave that for another day. It will look like finding the number of subsets of a set.
Yeah.
When you give you a set, it will be A, B, C. Okay, how should I be? D, E, F, G, H, I, J, K, L, M, N, O, P. I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the formula is what?
2N.
Right? Good. So how many subsets are you going to get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 15, right? 2 raised to the power 15. What is 2 raised to the power 15?
Yeah, I'm coming.
Ay.
32,768.
32,000
768.
subsets.
What if? Can I bring this in the question?
Why could not bring it? Why cannot bring it? Don't worry. Why could not give you anything? By the time then you use about 1 month to write it down. Why could not bring something like that? You know. Good. So that is how it is. That is how it is. Why could not bring something like this? Good. Why is not going to bring something like this. So let's continue. Good. Now example 1. Example 1. I give you example. You try before we solve it. Remember? You can also try it. You can also try it before we solve it here. So I have express the following. Example 1. Express the following in terms of the simplest possible sets. In terms of the simplest possible sets. Simplest possible sets. Right? Good. That's A is set 12. B is set 20. C is set 50. And D is 2 set 63. Wow. Very, very easy question. Good. So express this in terms of the simplest possible sets by fishing out for their perfect
B is
squares.
set 20.
Go. So let me see.
It is 20.
Set 20, yeah. B is set 20. You can also try it at home, before we solve it. Let's see. Good. Now A. Solution. Okay, what do you have? 12, right?
Yeah.
So what are the numbers you have for me?
4 times 3.
Okay. So that is 2 set 3. Simple, right? Now B. 20, right?
Yeah.
So what do you have for me?
5 times 4.
5 times 4. Okay. So I have 2 set 5.
Yeah.
Right? Good. Now C.
50.
50.
25 times 2.
25 times 2. So that is 5
2.
set 2, right?
Yeah.
Good. Now D. 2 set 63.
2 into bracket 29 times 57.
Okay.
What is equal to 3 root 7? 2 times 3 root 7.
Like this.
Yes.
Okay. Now per the rule, what are they doing?
I'm going to multiply.
So what
6 with 7.
that is 6. with 7, right?
Yeah.
Good. 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 That is 6 root 7. Good. Good. Now simplify this and let me see. Good. So I have simplify 12, root 12 plus root 75. Root 12 plus root 75. Simplify that and see. Good. Are we good?
Yeah.
So let's see. Now we are simplifying these guys, right? So my first step. So my first step.
3 times 4
Okay.
plus 25 times 3.
Good. So we try as much as possible to create perfect squares from the numbers given to us under the square root sign. Right? We create perfect squares out of them. So the multiplication you are actually looking for, if you are not getting a perfect square in it, then it means that you are amounting to nothing. Right? Good. So we simplify this, right?
Yeah.
We simplify that. But then we are trying as much as possible to get the same numbers under the square roots here, so that we can actually add the numbers outside.
Yeah.
If they are not the same, like said 5 plus say 2, this is never equal to say 7.